Welcome to episode 24 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today's episode is about supervised learning, essentially teaching machines with labeled examples.
Yes, it's like giving a student the answers along with the questions to help them learn faster. I'm excited to dig into how that works and what it means in the real world.
Let's start with the basics. Supervised learning is a fundamental type of machine learning where the algorithm learns from a data set that includes both the inputs and the correct outputs, what we call labels.
So the labels are like the teacher's notes that tell the machine this input corresponds to this correct answer. Without those, the machine would be learning in the dark.
Exactly. To give you an analogy, imagine teaching a child to recognize animals. If every photo you show them has the animal's name written underneath, like dog, cat, or elephant, the child can start linking features of the image to the correct category. That's supervised learning.
And in business, those labels could be anything, like whether a loan application is approved or denied, if an email is spam or not, or even the price of a house based on its features. This makes it super practical.
The two main types of problems in supervised learning are classification and regression. Classification is about sorting inputs into categories, while regression predicts continuous values.
Right, so classification would be, is this customer likely to churn or stay? Is this image a cat or a dog? Regression is more like, given features of a car, what will its selling price be?
Precisely. Mathematically, you can think of it like this. Your model is trying to learn a function that maps inputs to outputs, from features to labels, based on examples in the training data.
But Jonas, I've seen clients struggle with collecting good labeled data. It's often the biggest bottleneck. Because without accurate labels, even the smartest algorithm will give poor results.
That's a critical point, Amy. The quality of labeled data impacts how well the model generalizes to new, unseen data. Garbage in, garbage out, as they say.
Take healthcare, for example. If you want to build a system to detect diseases from medical images, you need expert radiologists to label thousands of scans accurately. That's expensive and time-consuming.
Yes, and it also underlines another key aspect. Supervised learning is resource-intensive in terms of data preparation.
But the payoff is often worth it. I worked with an automotive company that used supervised learning to improve predictive maintenance on vehicles. By labeling sensor data with whether a part failed or not, they trained models to predict failures before they happened.
That's a perfect example. The labeled data enabled the model to find patterns linking sensor readings to failure events, so the system could proactively schedule maintenance, saving costs and avoiding breakdowns.
And the beauty is, once you have a labeled data set, you can test and improve your model iteratively. You can measure accuracy, precision, recall, basically see how well the model is doing in predictable ways.
Those metrics are indeed important. They help determine if the model is trustworthy enough for deployment.
One thing I've noticed, though, is that some people confuse supervised learning with automation. They think once you train the model, it just replaces human judgment entirely.
That's a common misconception. Supervised learning models support decisions by learning from past examples, but they are only as good as the data and assumptions they're built on.
Exactly. And in many real-world deployments, especially in finance or healthcare, the model acts as a decision aid, and humans remain in the loop to interpret results and handle exceptions.
Another important historical note, supervised learning has been around for decades. Early algorithms like the perceptron from the 1950s laid the groundwork for modern classifiers.
That's impressive. And today we have everything from decision trees to deep neural networks applying supervised learning at large scales.
Indeed. Deep learning expanded supervised learning's reach, especially in areas like image recognition and natural language processing.
Talking about images, there was a fascinating case in retail where supervised learning helped automate quality inspection. Cameras labeled defects on products during manufacturing, teaching the system what to look out for.
That application illustrates the versatility of supervised learning. Wherever labeled examples map inputs to desired outcomes, it can be applied.
So for business leaders listening, a key takeaway is that building effective AI solutions with supervised learning starts with securing high-quality labeled data relevant to your specific problem.
And from a theory perspective, it's about choosing the right model type, classification versus regression, and understanding how to train and evaluate it properly.
Before we wrap, I'll add that supervised learning isn't a silver bullet. Some problems lack labeled data or have too much ambiguity, which is where other approaches come into play.
Well said. And that leads us nicely into our next episode, where we'll explore unsupervised learning, teaching machines when we don't have labels to guide them.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We love hearing from you, so leave your comments or questions. We might feature them in upcoming episodes.
Thanks for being with us today. Amy, want to close us out?
Until tomorrow, stay curious, stay data-driven.